The eagle has landed. Right. This is same Mangeya. And this part is on transformations, specifically translation. What is a translation? That's what is explained here. And questions involving translations. Then after watching this video, please like, share, and subscribe. First part, introduction. What is a translation? First thing, you have to know how to identify a translation and how to describe a translation. Then the first part, identifying a translation. Number one, you check on the size. Size remains the same. Number two, direction remains the same. That's called a translation. So check on the size and direction. If direction is the same, size is the same, that's called a translation. Right? Please take note of that part. That's called a translation. Size the same and direction the same. That's called a translation. Then how do you now describe a translation? Describe a translation. Number one, you check. You have to state that it's a translation. State that it's a translation. What they say, describe fully the single transformation that have mapped this shape onto this shape. Then first thing, if it's a translation, you have to state that it's a translation. That's the first thing. Then number two, state the vector of translation or the translation of vector. These two things, then we have described fully or completely that translation is a transformation. How do you find the translation vector now? Use this formula. You say original point plus translation vector is equals to image point. Original point plus translation vector is equals to image point. Original point plus translation vector is equals to image point. That's the formula that you have to use. So if you want to find the original point, you just take this side, this one, this side. You subtract image point minus translation vector. That's original point. If you want to find the vector, you can just take the original point, this side. Right? It will be translation vector equals to image point minus original point, just like that. So it's just this formula that the investor one. Questions. Question number one. Translate triangle A by, this one is vector 5 minus 6. Triangle A is here. One translate by vector 5 minus 6. So you can use the counting method, or you can just use this formula. This formula works very well. How do you use this formula? You take all the points of the triangle. Like you take this point, how many points? Let me take this point first. What are the coordinates of this point? Minus 2, 5. You take another point. This point is minus 2, 1. You take another point of the triangle. This point is minus 4, 3. Then after that, you add the translation vector. You add the translation vector to each of these points. So the vector actually translates all these points. 5 minus 6, 5 minus 6. So it's to find the image point. Right, the first part, this one we can add minus 2 plus 5, add the corresponding values. I'm sure you've done vectors. If not, check, there is a video that I've put on YouTube. It's on vectors. Minus 2 plus 5 is 3. 5 plus minus 6 is minus 1. Then minus 2 plus 5 is 3. 1 plus minus 6 is minus 5. Then this one, minus 4 plus 5 is 1. 3 plus minus 6 is minus 3. Then plot these points now. The first part is 3 minus 1, x3, y minus 1. You plot. Next, x3, y minus 5, you plot. Next, x1, y minus 3, you plot. Then you join the points. Right, if you can check, direction is still the same. So this will be called the image of triangle A, just like that. So triangle A is called the original, and this one is called the image and original, just like that. Next question, number 2. Translate rectangle A by 7, 5. Or before that, if we were to use the counting method, that was also going to work. This part, like if I can say 5 minus 6, this part is for x, this part is for y. X increases going to the right and decreases going to the left. Y increases going upwards and y will be decreasing going downwards. So if it's plus 5, you count on the positive direction of x, 5 boxes. Then minus 6, you count on the negative direction of y, minus 6 boxes. Like each point by point, like this point, we start with this point. X, you count 5 to the right. Both is positive. It's 1, 2, 3, 4, 5. So that's the x direction. Now you have to count minus 6 is on the y direction. Y is going downwards. You count 6. 1, 2, 3, 4, 5, 6. So the image will be at this point. Let's do the same on this point. Right. Find 5x and minus 6y. 1, 2, 3, 4, 5. Then 6 downwards. 1, 2, 3, 4, 5, 6. So this will be, you get the same point, right? And this one, 1, 2, 3, 4, 5. Then 6 downwards. 1, 2, 3, 4, 5, 6. So you get to the same points. This one is called the counting method. But adding each point actually is a bit better, straightforward. Counting is easier, but you can make errors given that the scale is different. You have to take note of the scale now. Right, then translate rectangle A by vector 7, 5. Label the new shape B. You can take all the points, or let's just use the counting method. You count 7x, then you count 5 on the y, positive y. So you count like this one. First one is 1, 2, 3, 4, 5, 6, 7. Then 5y, 1, 2, 3, 4, 5. So the image will be at this point, right? Then the next part is this one. You count 7, 1, 2, 3, 4, 5, 6, 7. Then 6, 1, 2, 3, 4. It's 5. It's 5. Yeah. Then this one, you also count 7 and 5. 1, 2, 3, 4, 5, 6, 7, and 5. 1, 2, 3, 4, 5. So it's here. Then this one, last one. 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5. It's here. So your shape. Your shape will be like this. Let me remove these things. Your shape will be like this. That will be rectangle B, just like that. Even if you're going to use the counting method, the formula. You take this point, for example. This point is what? Minus 5 minus 3. You add the vector 7, 5. You get your image. Then take the other point. This one is minus 5 minus 4. You add the vector. You get your image point. You take another point. It's this one. Minus 3 minus 3. You add the vector 7, 5. You get your image point. You take the last point. This one. Minus 3 minus 4. You add 7, 5. Then you get your vector A. Let's start with the first one. Minus 5 plus 7, you get 2. Right, you get 2 here. Then next one, minus 3 plus 5. Minus 3 plus 5 is 2 also. Like this. Then on the second one, right, then on the second one, right, it's a, let me exit this mode. Right, the second one, you add minus 5 plus 7. What do you get? You get 2. Then minus 4 plus 5, you get 1. Then on the other one, it's minus 3 plus 7 is 4. Minus 3 plus 5 is 2. Then minus 3 plus 7, 4. Minus 4 plus 5, 1. Then you plot all these points. You usually get the same rectangle. Done. Right, I'm sure you've seen it. Then let's do this one. Translate trapezium A by vector 0, 4. X, and this one is Y. Y moved 4 steps, but X, no. You can add each and every point. This one is minus 4, minus 3. You add the vector 0, 4. You get your image. You take another original point, which is this one, minus 3, minus 2. You add vector 0, 4. You get your image. Then you take another point like this one, minus 2, minus 2. You add the vector 0, 4. You get your image point. You take another point, this one, minus 1. Minus 1, minus 3. You add the vector 0, 4. You get your image point. Right, let's do the adding. Right, adding minus 4 plus 0 is minus 4. Minus 3 plus 4, 1. Minus 3 plus 0, minus 3. Minus 2 plus 4, 2. Minus 2 plus 0, minus 2. Minus 4 plus 4, 2. Minus 1 plus 0, minus 1. Minus 3 plus 4, 1. Just like that. Then you plot the points. First one, minus 4, x minus 4, y 1. It's it. X minus 3, y 2. Yeah. Next, x minus 2, y 2. It's it. Next, x minus 1, y 1. This one. Then you join your points. This will be your trapezium translated by vector 0, 4. Right. You can just do the counting method also. X, no movement, but y is 4 steps. So each point will just move 4 steps upwards. Like this one, 1, 2, 3, 4. It will be this one. Then the other point, you can take this one. It will move 1, 2, 3, 4. You still get the same points. Then this one, 1, 2, 3, 4. Same points, this one, 1, 2, 3, 4. Same points, right? That's what you just have to do. But please don't put these fun items. Don't put this line. Don't put them, right? Use the counting method, yes, but don't put those things. Right, next part. This one's for your homework. It's the same as that one. Then let me check. Do we have a different one now? This one's still the same. You just add each and every point of this triangle. 3, 3. 3, 3, you add to the vector. You take this point, it's 1, 3. Then this point is 1, 1. So 3, 3, 1, 3, and 1, 1. You add the vector. You plot the points. That will be your image. Right, now this one, we have a shape that is already drawn for you. That's the image. Write down the transition vector that would take A to B. So use the formula. Transition vector is equals to image point minus original point. Because we said original point plus transition vector is equals image point. That's our formula. So if you want to find the vector, you take the original point to the other side. It will be image point minus original point. You just take any of the points that you want there. Like in this case, you can take this point, but take the corresponding points, this point and this point, this and this, right? So you take the image first, A onto B, or A to B, which means B is the image. It came from A. A is the original, B is the image. So you say image, that is the point, B point. We can take this point is 3, 6. So it will be 3, 6 minus original point is 4, 1. This one is 4, 1. It's 4, 1, like this. Then the vector 3 minus 4 is minus 1. 6 minus 1, 5. Done. That will be the vector. Even if you would take another point, like let's say you have to choose this point here and this point. Just make sure they are the corresponding points, and you always have to start with the image. That this point, it will be 2, 7 minus the same point on the original is 3, 2. 3, 2, this one, x 3, y 2. Then you can say 2 minus 3 minus 1. 7 minus 2, 5. You can see you get the same answer. So you take any of the points that you want. Even if you would take this one and this one, the answer was still going to be the same. Let's try it. 6, 2 minus this point is 3, 1. It's what? It's 2, 6. 2, 6. You start with x. You start with x, not with y. It's 2, 6. Then minus, then 3, 1. So it will be 2 minus 3 minus 1, 5. Right? You still get the same answer. So translation vector is equals to original image point minus original point. Done. Right? We have these funny dudes. Part A is saying write down the transition vector that will take A to B. A to B. I can choose which point, this point, and this point. And please take note, it's A to B. B is the image. So you say image point, which means point of B on B minus point on shape A. So points, I mean this one. This one the point, this one the point, the point, the point, the point, the point. How many points do we have? 1, 2, 3, 4, 5, 6. Any of these 6 points, just take one. Just take 1 point, any of the points, right? Then make sure you take the corresponding one on shape A. So I can choose this one. So the coordinates is 4, 4. Minus on A, the original is 1, 1 minus 1. So the vector will be 4 minus 1, 3, 4 minus 1, 5. That's the vector. Done. Right. Now the second part, B, write down the transition vector that would take B to C. C is the image and B is the original now. C to B. B to C, B to C. So you take C, I'll take I can choose this one, this one, this one, any of the 6 points. So what are the coordinates of this one? You start with the image, that's C, minus 1, 1. Minus, then this point, 4, 2, x 4, y 2. Then subtract, minus 1, minus 4, minus 5, 1 minus 2, minus 1. So this will be the translation vector. Done. Right? Then on this one, describe fully the single transformation that maps shape A onto shape B. Right? You write this one, check on the signs. Size is the same. Direction is the same. It's a translation. So write translation first, that's a mark. Then you have to now write the vector of translation. Vector, let's find the vector now. The vector, I can take this point and this point. Right. So this point and this point is 4. It's A onto B. So you start with the point on B, on shape B. So it's minus 1, minus 1. Minus 1, minus 1. Then minus. The same is 4, 2. Then if you can subtract, it will be minus 5. Then minus 3. So vector minus 5 minus 3. Then you are done. That's a translation. So you have to state translation, then the vector of translation. Then this one also, describe fully the single transformation that maps A onto B. The same thing, check direction is the same. The shapes are facing the same direction. Check the size is the same. So this one is a translation. So you have to write translation, then vector now. Let's find vector. I can take which point? This point and this point. It's A onto B. B is the image. So this point is 1 minus 2. X1, y minus 2. Then minus this point, minus 4 minus 1. Then subtract, you get 5. You get minus 1. So it's 5 minus 1. Done. Just like that. Even if you were to count x, it will be 1, 2, 3, 4, 5. You write your 5. Then y, it will be minus 1 going downwards. Still, it will work. Just like that. Same Mangeya, signing out. Check for the other types of transformations, right? They are there. Videos are there. I've made lots of videos. Thank you.